Hello everyone, my name is Sajida Azmir. Today I'll be presenting on the fundamentals of computer system and network. Today I will cover 13 key areas from the CPU's internal components to different types of computer networks. First, we look at the internal components of the CPU. Here, we can see the main parts inside the CPU. Each part plays an important role and together they help the computer run instructions quickly and accurately. Now, let's look at the main parts inside the CPU and what they do. The arithmetic logic unit handles calculations and comparisons. The control unit manages how instructions are executed, and registers are tiny spots for very fast temporary storage. Cache memory stores data that the CPU uses frequently so it can work faster. The bus interface is like a communication highway moving data between the CPU, memory, and other components. The clock keeps everything running on time by sending regular timing signals. Now, let's talk about what the CPU actually does through its core functions. First, it fetches instructions from memory, then the control unit decodes them to figure out what needs to happen. Next, it executes the task like a calculation. It also controls the program flow to decide what instruction comes next. Finally, it handles interrupts which allow the computer to pause a task for something more urgent and then come back to it. Now we'll see how the different hardware components of a computer work together. The CPU acts as a primary coordinator, running calculations and managing almost every task. RAM is the active memory. It holds what you are working on right now, so the CPU can access it quickly. For long-term storage, we use hard disk drives which use spinning disk or solid-state drives which use flash memory, and they are much faster. The graphics processing unit is a specialist. It's dedicated to display high quality images, videos, and 3D graphics for things like gaming. The power supply unit converts wall power into the exact voltage needed to keep the computer safe and running. Ports like USB and HDMI are the gateways that allow us to connect external things like monitors and printers. Let's explore the types of storage media, their uses, and the purpose of each. We use hard disk drives for large amount of data at a lower cost, while solid-state drives are used when we need fast startup and loading times. Flash drives are our portable solution for moving files between different computers easily. Floppy disks were mainly used with all the computer systems, while CDs and DVDs use lasers to store music and movies at a low cost. Now let's see how computers represent data. Computers don't see the world like we do. They need data to be represented in a specific way. Everything is converted to binary zeros and ones. Numbers, letters, images, and sounds are also stored using binary codes. Proper representation is vital for fast processing, optimized storage, and entering different systems can communicate reliably. Types of data representation. Text representation. Computer uses specific numerical codes to stand for every letter, digit, and symbol. Number representation are represented using binary and number systems such as decimal and hexadecimal. Image representation. Digital images are broken down into a massive grid of tiny dots called pixels. Audio representation. Since real-world sound travels in continuous waves, computers must measure these waves at regular intervals to convert them into data. Video representation. Video is a combination of the two previous types. It stores a sequence of moving images coordinated with digital audio track. Now let's look at how encryption can be used to represent data. Encryption is basically a way to keep data safe. It changes the data into a form that looks like random letters, numbers, or symbols so that anyone who shouldn't see it won't be able to understand it. The data is still there, but its appearance has changed. This is really useful when we are storing sensitive information or sending data online because it keeps it safe. This shows how a message is protected with encryption. The sender changes the original message into a secret code using an encryption key. Only the receiver with the correct key can change it back to the original message. In this slide, we are going to see how computers represent images and sounds in computer systems. Now we'll look at how computers store and represent images. Computers store all data as zeros and ones. So even images are converted into numbers. Images are made of tiny dots called pixels, and each pixel has color information stored in a numerical form. The color of each pixel is made from a combination of red, green, and blue values. An image with more pixels has higher resolution and appears clearly. All pixel data is stored internally using binary form. Now we'll look at how computers store and represent sound. Sound is the real world moves as a continuous wave, but computers can't store continuous waves directly. To store sound, computers take measurements at regular intervals. These are called samples. Each sample shows how high or low the wave is at that moment. These heights are then converted into numbers, and the computer stores them in binary, which is just zeros and ones. Some common sound file types that use this method are MP3 and waveform audio file format. Now let's talk about how compression can aid the storage of data, images, and sounds. In this slide, we are going to see what data compression is and the main types used. Data compression is a way to reduce the size of files so they can take up less storage and can be shared or downloaded faster. It doesn't change the actual information, just the way it is stored. There are two types of compression. The first one is lossless compression, which reduces file size without losing any data so the original file can be fully recovered. The second is lossy compression, which removes small, less noticeable details to make the file even smaller. Through the quality might be slightly reduced. Compression is used for many types of files like documents, images, audio, and videos, making them easier to store and manage. Let's move on and see how compression helps with storing files. For data, compression makes documents smaller by shortening, repeating parts so they can be shared faster without losing important information. For images, it groups similar colors and removes tiny details we don't really notice, which let us save lots of photos without using too much space. For sound, compression removes audio parts humans can't hear, making it possible to store many songs or stream music without using a lot of storage or data. Basically, compression helps us keep more files in our device and share them quickly and easily. Now, let's take a look at logic gates and what they are used for. Logic gates are small electronic circuits that make simple yes or no decisions. They take inputs of 0 or 1 and give an output for 0 or 1. Logic gates work using Boolean algebra, a type of mathematics for true or false values. By connecting different logic gates, we can build complex circuits like flip-flops, counters, and processors. Logic gates are used in processors, memory devices, phones, laptops, and tablets, helping these devices process information and work properly. On this slide, we are looking at two important logic gates, OR gate and AND gate. The OR gate gives an output of 1 if any of its input is 1. So even if only one input is true, the output will be true. The AND gate is different. It gives an output of 1 only if all of its inputs are 1. If even one input is 0, the output will be 0. Now let's look at some other types of logic gates. A NOT gate is an inverter. It has only one input and gives the opposite output. If the input is 1, the output is 0. If the input is 0, the output is 1. A NAND gate is the opposite of AND gate. It gives an output of 0 only if all inputs are 1. Otherwise, its output is 1. A NOR gate is the opposite of OR gate. It gives an output of 1 only when all inputs are 0. An XOR gate gives an output of 1 only if the inputs are different. So, if both inputs are the same, the output is 0. Finally, an XNOR gate is the opposite of XOR gate. It gives an output of 1 only if the inputs are the same. All these logic gates work together to help computers process information and make decisions based on different input conditions. In this part, we will look at how computers can connect through different networks and what each type is designed to do. Let's start with private area network. It is the smallest type of network and connect devices close to one person, like a phone, tablet or laptop. For example, connecting your phone to wireless earbuds. Next is local area network. It covers a home, office or school, letting computers and devices share files, printers and internet connections. For example, the network in a school computer lab. Then we have metropolitan area network. It is larger and can cover a whole city or town, connecting multiple local area networks together. For example, a city government network linking public offices or libraries. Now, let's look at wide area network, enterprise private network, and virtual private network. A wide area network connects networks over large distances, even across countries or areas. For example, a company with offices in multiple countries can use a wide area network to connect all of them. An enterprise private network is used by organizations for internal communication. It helps employees share files and resources safely within the company. A virtual private network creates a safe private connection over the internet. It's often used to safely access company resources from home or public networks. These networks show how computers can be connected over larger areas while keeping communications safe and efficient. Next, we'll learn about the hardware, software, and transmission media that are used to set up and run computer networks. On this slide, we are looking at the hardware and software used in computer networks. For hardware, the most important devices include network interface cards, which let a computer connect to a network, routers, which connect different networks and decide the fastest path for data, switches, which send data only to the planned device within a network. Other devices like modems, firewalls, bridges, and repeaters help with internet access, security, and extending the network. For software, networks rely on programs to manage communication and protect data. Network operating system manage shared resources and connection. Protocols make sure data is sent and understood correctly. Security software protect the networks from attacks. Monitoring tools track performance and alert administrators if there's a problem. Virtual private network software creates a safe private connection over the internet. On this slide, we are looking at how data travels between devices using transmission media. Wired media uses cables. This includes cables like twisted pair cables, which are common for home and office networks. Coaxial cables, often used for cable TV and broadband internet. Optical fiber cables, which can carry large amounts of data very fast using light. Then we have wireless media that doesn't need cables. Radio waves pass through buildings and are used in AM or FM radios and cordless phones. Microwaves need line of sight and are used in mobile communication and TV distribution. Infrared waves are for short distances like TV remotes, wireless mice, or printers. In this part, we'll see various technologies that help the World Wide Web run and connect people around the world. On this slide, we are looking at the World Wide Web and the technologies that make it work. The web is all the public websites you can access online. Using hyperlinks, you can jump between pages to find and share information. People use it for browsing, watching videos, shopping, and connecting with others. Three main technologies make the web work. Web browsers like Chrome or Firefox let you access and view websites. Web servers store and deliver web content over the internet. Web protocols are rules that ensure computers understand each other and send data correctly. Together, they let us communicate, learn, shop, and enjoy entertainment online. Finally, let's look at different types of computer network topologies and what each one is used for. Bus topology, it connects all devices along a single cable. It is simple and cheap, but the network stops if the cable breaks. Star topology, it connects devices to a central hub. It is reliable since one device falling doesn't affect the network. Ring topology, it links devices in a circle with data moving one way. It is organized, but a single failure can break the network. Next, we'll explore some topologies: mesh, tree, and hybrid. Mesh topology. Every device is connected to every other device. It is very dependable but uses a lot of cables. Tree topology. Devices are arranged like a tree, combining star and bus layouts. It is easy to manage in large networks. Hybrid topology. A mix of two or more topologies taking the strengths of each for flexibility and performance. That's the end of my presentation. Thank you for listening. I hope it helped you understand the topics clearly.